Our universe is a symphony of motion. Planets waltz around stars. Stars pirouette in galaxies. Even the smallest particles, the atoms themselves, possess an intrinsic spin. This constant motion, this ubiquitous spin, is more than just a cosmic dance. It's fundamental to the very fabric of existence. One of the key concepts that help us understand this swirling, spinning reality is the radius of gyration. It's a deceptively simple idea with profound implications, a concept that bridges the microscopic world of atoms to the grand scale of celestial objects. The radius of gyration provides a unique lens through which we can analyze and predict the behavior of spinning objects. It allows us to quantify the distribution of mass within an object and understand how this distribution affects its rotational motion. In essence, the radius of gyration is a powerful tool that unlocks the secrets of a spinning universe. Imagine a spinning figure skater. As they pull their arms closer to their body, they spin faster. This increase in spin speed is directly related to the distribution of their mass relative to the axis of rotation. The radius of gyration helps us quantify this relationship. Simply put, the radius of gyration is the distance from the axis of rotation to a point where we can imagine the entire mass of an object concentrated without changing its rotational characteristics. It's like finding the sweet spot of an object's mass distribution in relation to its spin. A smaller radius of gyration indicates that the mass is concentrated closer to the axis of rotation. This results in faster spin speeds for a given amount of rotational energy. Conversely, a larger radius of gyration implies a wider distribution of mass, leading to slower spin speeds. This concept, though seemingly abstract, has profound implications for understanding the motion of everything from spinning tops to rotating galaxies. Let's bring the radius of gyration to life with a few examples. Imagine a baton twirling through the air. A baton with most of its mass concentrated at its ends will have a larger radius of gyration and rotate more slowly. A baton with weights closer to the center will have a smaller radius of gyration and spin faster. Picture two cans, one filled with soup and the other empty. If you roll them down an incline, the empty can, with its mass concentrated near the center, will roll faster. The soup can, with its mass distributed further from the center, will have a larger radius of gyration and roll more slowly. A gymnast tucking into a tight ball during a somersault reduces their radius of gyration, allowing them to spin faster. When they extend their body, their radius of gyration increases, slowing their rotation. These examples illustrate how the radius of gyration helps us understand the relationship between mass distribution and rotational motion in everyday objects. The radius of gyration isn't just a concept confined to everyday objects. It plays a crucial role in our understanding of the universe at its grandest and most fundamental levels. In physics, the radius of gyration helps us model the behavior of spinning objects from atoms to galaxies. For instance, the moment of inertia, a key concept in rotational motion, is directly proportional to the square of the radius of gyration. This means that an object with a larger radius of gyration will resist changes in its rotational motion more strongly. Furthermore, the radius of gyration is crucial for understanding the stability of spinning objects. Objects with a larger radius of gyration are generally more stable and less likely to topple over. From the spin of subatomic particles to the majestic rotation of galaxies, the radius of gyration is an essential concept for unraveling the mysteries of a universe in perpetual motion. Section 5. Engineering Marvels, Radius of Gyration in Design. The radius of gyration isn't just a theoretical concept. It has practical applications in various fields, particularly in engineering. Engineers use this concept to design structures that are both strong and stable. For example, the design of buildings, especially skyscrapers, must account for wind loads and seismic activity. A building with a larger radius of gyration, achieved by distributing its mass further from its vertical axis, will be more resistant to swaying and toppling. Similarly, the design of aircraft, automobiles, and even bicycles takes into account the radius of gyration to optimize performance and stability. For instance, a car with a lower center of gravity and a wider wheelbase will have a larger radius of gyration, making it less likely to roll over during sharp turns. The radius of gyration is an indispensable tool for engineers, allowing them to create structures that can withstand the forces of nature and the demands of human use. Section 6. Life's Balancing Act, Radius of Gyration in Biology. The natural world also provides fascinating examples of the radius of gyration at work. From the graceful movements of a cheetah to the stability of a redwood tree, living organisms have evolved to optimize their body structures for movement and balance, often unconsciously utilizing the principles of the radius of gyration. Consider the cheetah, a creature built for speed. Its slender limbs and tail act to distribute its mass in a way that minimizes its radius of gyration, allowing for rapid acceleration and agile turns. On the other hand, a redwood tree, reaching for the sky, has a wide base and a tapering trunk, a design that maximizes its radius of gyration, providing stability against strong winds. From the tiniest insects to the largest whales, the radius of gyration plays a subtle but crucial role in the form and function of living organisms. Section 7. Real-world wonders applications we see every day. The radius of gyration might seem like a complex scientific concept, but its applications are woven into the fabric of our daily lives. We see it in the design of everyday objects like bicycles, where a lower center of gravity and a wider wheelbase increase the radius of gyration, making them more stable. The stability of tall furniture, like bookshelves, is also influenced by the radius of gyration. A wider base increases the radius of gyration, making it less likely to tip over. Even the design of sports equipment like tennis rackets and baseball bats takes into account the radius of gyration to optimize swing weight and performance. The next time you ride a bike, admire a skyscraper, or marvel at the stability of a tree, remember the invisible hand of the radius of gyration at work. Section 8. Beyond the Basics, Advanced Concepts and Applications. The radius of gyration, while a fundamental concept, has far-reaching implications beyond the basics. In advanced physics, it plays a crucial role in understanding the behavior of rotating black holes, the dynamics of planetary rings, and the stability of star clusters. In materials science, the radius of gyration helps characterize the structure of polymers and other complex molecules, providing insights into their properties and potential applications. Researchers are constantly finding new and innovative ways to apply the concept of the radius of gyration to solve real-world problems, from designing more efficient wind turbines to developing novel drug delivery systems. The radius of gyration, though a seemingly simple concept, continues to push the boundaries of our understanding of the universe and its many wonders. Section 9. Unlocking the Secrets of Spin Conclusion. The radius of gyration, a concept that quantifies the distribution of mass relative to an axis of rotation, might seem abstract at first glance, yet it holds the key to understanding a universe in perpetual motion. From the graceful pirouette of a figure skater to the majestic rotation of galaxies, the radius of gyration helps us unravel the mysteries of spin. It allows engineers to design stable structures, biologists to understand the biomechanics of movement, and physicists to probe the fundamental laws governing the cosmos. As we delve deeper into the intricacies of the radius of gyration, we gain a profound appreciation for the elegance and complexity of our universe, a universe where even the smallest spin can have the grandest consequences.